Awesome. Thanks so much, Jay. Yeah, so today I'm super excited about talking about exploring data lake, how we can use the data that's in our ODX data lake to gain insights when we query it directly. So yeah, let's go ahead and jump right in. You know, I think the first question that always comes up is, why would I store my data in data lake? And I think the first most obvious answer to that question is that it's cheap. It's practically limitless, very inexpensive storage, right? We can store just about as much data as we want. It's very inexpensive. Okay, that's great. So I have my data in data lake, but what do I do with it once it's in there? Well, we can gain insights from the data directly in the data lake just by querying that data directly. So we can even build reports directly off of that data if we wanted to. It's not the most efficient. It's actually much more efficient to query directly from the data warehouse, but you'll likely have a lot more data available in your data lake. So if you wanted to do data exploration, understand what data you might have available to you to gain insights from, you can start querying your data lake directly. The data lake is also a preferred place for data scientists to build machine learning algorithms using things like Databricks and other tools. So you can connect directly to the Azure Data Lake storage using Databricks and using other platforms. We'll cover that in another session. Today, what we're going to cover is mostly just connecting to the data lake using some basic tools like Azure Data Explorer and being able to query the data lake using the SQL syntax using the serverless SQL pool. So let's go ahead and jump right in. So first of all, what is an Azure Serverless SQL Pool? Well, it's a big data query service where you can query data directly using native T-SQL language. And the nice thing about it is you're not paying for a server. So this is a pay per query service. Now, the downside to a per query service is you're not going to be able to depend on the performance of that service always being super fast, right? It takes a couple minutes for it to spin up, and depending on how many active users are currently using Azure, you might see slower performance or faster performance. So it's not meant for super heavy duty loads. You also can't persist data in Azure Serverless. There's no actual storage of data. The data is stored in a data lake, as opposed to a dedicated SQL pool, which we covered in the last session, where data is actually persisted in this database. The serverless SQL pool, you can create views, you can run queries, but the data isn't persisted in the SQL pool in serverless. One of the major benefits of using serverless is that it is very inexpensive. I would say it's probably the most inexpensive SQL option in Azure, given that you're only paying per query. We'll see as I go and spin it up. I think it said something around $100 per terabyte, and that's again per query. So as you're querying data, if you've queried a full terabyte of data, then you'll pay only $100, which again is very inexpensive when you're comparing that to Azure SQL Database or a dedicated SQL pool. Okay, now before we start to query and explore the ODX storage on an Azure data lake, we need to understand what is the file structure created by the ODX. So in essence, this is the file structure that gets generated. As we can see, we're going to have a folder for each data source. Every data source that's created in there is going to be directly in the root container. So if you navigate to that container, you'll see a list of all your data source folders. Within those, there's going to be a folder for every single table, right? And this is prefixed by the schema. So you have schema_table. And then within each table, you're going to have a couple of folders. First of all, the work folder, and that's going to contain uncommitted transactions. So as executions are running, data, it gets loaded into the work folder. And then as soon as that load is completed successfully, that data gets moved into the data folder. And this is to ensure that you're not querying, you're not pulling data from uncommitted transactions or partially committed transactions, right? So once it's in the work folder, that means it's being worked on, it's moving, and then once it's completed successfully, it'll move into the data folder. So the data folder in there this is actually what we call the version folder. So every time you execute a table in the ODX, it's going to create a new version of that data. That's because, last week's version of the data may not be the same as this week's version of the data. Schemas change, things change. Every time you run a full load of that table, it's going to create a new version for us. That is, of course, unless we've enabled incremental loads. If we have incremental loads and the schema of the underlying data set hasn't changed, it will just start creating these Parquet files in batches inside the data folder. But every time there's a schema drift, meaning that the table structure, a data type, or a field has been added, you'll get a new version, and that'll initiate a full load of that data set. So you have a brand new version of the data. Okay, so within the version folder, you'll have a model.json file, and this is just metadata for the ODX. You can find some useful information in there. It has the table GUID. It has an incremental max values for the ODX, so that's how it's handling the incremental loads. Every time it gets that last max value, it's going to write that to the model.json file. And so, but it's not going to have any of your data or real insights in there, but it might be useful for troubleshooting. Okay, and then within that is another data folder. And then in there is where you'll find the actual Parquet files that hold the data within each of these tables that you're executing. So data gets executed, pulled by the ODX, and then written into Parquet files inside that ODX. So the first incremental load is going to be all data in this _0000 Parquet file. Any subsequent incremental loads, you'll have 0001, 0002, 0004. Sometimes it can skip the sequence, and that's because it's recorded by batch number and not necessarily by sequence. Okay, so if you see numbers being skipped, don't freak out. That's actually expected. That means that the ODX was busy handling other executions during this batch or executing other tables during that batch and not executing this table. But the next batch, that number will be recorded in the file name there. All right, so that is the file structure of our ODX. So let's get into now examining this data. First of all, if you're going to follow along with me today, you will need access to your Azure Data Lake, and this is your ODX storage in your Azure Data Lake. We are going to create a Synapse Workspace today and use Synapse Studio to query the data. So you're going to need permission to create that if you want to go through that piece. You'll also need access to an instance of SQL Server Management Studio and Azure Storage Explorer. Okay, so we're going to be using these tools today as well. If you want to know, how to install those are pretty straightforward, easy to find online. You just query SQL Server Management Studio or Azure Storage Explorer. You'll find the downloads really quick. So here's the steps we're going to cover today. There is a guide on this in the KB article, so you can follow this guide if you want more information, if you want to go look at this later. But of course, I'm going to walk through all these steps here today. So the first way to explore the data lake is through Azure Storage Explorer. Now, the first thing I'm going to do here is I'm actually going to navigate to my TimeXtender Tuesdays resource group. This is the same resource group we've been using all along. And I'm going to go to my TX Tuesdays storage. So in the actual Azure portal itself, there is a preview version of a web-based Storage Explorer. So you can actually, within Azure portal, go through and see your containers. We have TX Tuesday's container. We can see I've loaded a single data source in here, and we can navigate through and see all of my different tables. As I mentioned, again, that structure, the file structure here, we have the data source name. We have all of the tables, right, prefixed by the schema. And then within that, we have that work folder. And then we have the different versions of our data. We can see in here, I've actually loaded this data source twice now and done a full load. I didn't have incremental loads enabled. So we have two different versions of the data. So we can go in here and see inside this, in the data folder, we have this Parquet file. Great. If you're not too keen on using the web-based interface here, it can be a little clunky at times. You also aren't able to upload files if you ever want to do that. You want to use the desktop version of the Storage Explorer. So it's a little bit easier to use, in my opinion. Again, you can navigate through here. You can go and see all the same stuff. You can download files. You can upload files. So you can do a lot of neat things using the desktop version of Azure Storage Explorer. Okay, so now again, we haven't even seen any data yet. So to use Azure Storage Explorer to see the data, you actually need to download the Parquet files. So you'd need to download the Parquet files, and you can open them up here and we can see them. So here is my department table, listing all of my departments from that SQL Server database. That's actually the AdventureWorks data source. So I have all of these listed here, and that's great, but I'm not able to query them. I'm not able to join or filter or do any complex queries like that. So it's okay for some quick troubleshooting. You know, if you have some issues with the data, you're not quite sure if all the data is there in the ODX, you can download this Parquet file and you can search through here, and you can see something quick. But if you really need to start validating data, looking into it deeper, adding some filters and some joins, you'll want to be able to query the data like you can query it in SQL. Well, I'm going to show you how to do that next. So in order to do that, we need to create a Synapse Workspace. So a serverless SQL pool exists only within a Synapse Workspace. So you need to create that first. Let's go through those steps. Okay, so here I am in the Azure portal. What I can do is type in Synapse, and we have here Azure Synapse Analytics, and this is to create a Synapse Workspace. We can click on this and click Create. So this is going to walk me through the steps of creating a new Azure Synapse Analytics Workspace. We can define the resource group. And this is the managed resource group. You don't need to specify it, but that's if the resources within your workspace, if you want to put them in a different resource group, you can do that. You want to define a resource workspace name. I'm going to call this TX Tuesdays. Oops. Okay. Account name. So this is linking an Azure Data Lake storage account to your workspace. Now, again, Azure Synapse Analytics is built on top of the foundation of Azure Data Lake Storage Gen 2. So in order to really use it at all, you actually need to link it to an Azure Data Lake storage. So we go in here, we just type in the name of our Data Lake storage. We have our TX Tuesdays storage and our TX Tuesdays container. And then we can go through and define security. This is going to ask for a SQL Server administrator, just like a normal SQL Server. You need to start with those administrator credentials. You want to put that information in there and get that sorted. And then we can go through here, you know, defining additional security things. I leave all these as default. I've done it a couple times now. But of course, you can modify them for your own tenant. Virtual network, I haven't been using that. Allow connections from all IP addresses. Again, I've left everything else as default, and I've been able to query pretty well. This is really if you want to have a more secure, more locked down version of the workspace. You can, of course, do that. All right. Now, instead of actually going through and creating this and having to wait for that to deploy, I went ahead and created my own already. And that is going to be right in here. So if I go back to home and I go to TX Tuesdays, and if we go to my TX SQL pool, another way to create that workspace is actually to open up your dedicated SQL pool, and you'll have a button here that says Create Synapse Workspace. And this is a great way to do it because it'll link your dedicated SQL pool and embed that SQL pool into your workspace, which is really nice because then you can use your dedicated SQL pool along with the serverless SQL pool. So I'm going to go ahead and hit Launch Synapse Workspace. And again, that's because I've already created this workspace. I didn't want to have to wait for it to deploy because we do have a lot to cover today. You can go in here to the data pane, and then under my databases, you can see my dedicated SQL pool is already linked, which is nice. So I can go through and start querying this data. And then if I click on linked, we have my Azure Data Lake Storage Gen 2. And this is the database that we created for TimeXtender Tuesdays, right? So we have my TimeXtender Tuesdays container. And again, we can go through and explore that data lake just like we did in the Storage Explorer, right in here in the Synapse Workspace. So we have all of my tables listed out, prefixed by the schema. We can go down even further. We can see different files. But the nice thing about the Synapse Workspace is once we actually get to a Parquet file, you can right-click on that Parquet file and click Select Top 100 Rows. Click Run, and it'll generate a query for you, which will allow you to query those files directly. So, and you can see here, very similar T-SQL, right? Select Top 100 star from, and then the only thing that's really different here is to define that data lake file itself. You're actually putting in the file path in there, right? So we're going to do that. But we can actually take this same query and we can run the same query within our Synapse, within Management Studio. But in order to do that, so I'm going to copy this and let's go over to our SQL Server Management Studio. And you can see that's actually right here. I've already pasted that in, but I'll go ahead and paste that right here. And we can just query this. But if I do, I'm already connected to the same that same serverless SQL. So a couple things that I forgot to mention. So if you are going to query this inside of SQL Server Management Studio, what you do need is you need the endpoint, the serverless endpoint. So if you go to the resource, this is my Synapse Workspace resource. Again, within my resource group, okay? And you have all of the different server names here, dedicated SQL endpoint, serverless SQL. We need the serverless SQL endpoint. We copy that to the clipboard, and then we go into SQL Server Management Studio. We go to connect, and then we paste that endpoint as the server name right in there. And then we use the same administrator login and password that we created when creating the workspace. And this will likely match the same as your server that we created a couple weeks ago. So you can create that workspace, and that's essentially what I've done right here. And then from there, once you're connected, you can actually query the tables. All right, so I'll hit execute, but it looks like it says it cannot find the credential. So what I need to do is I actually need to create a server scoped credential for my workspace. And this is how you do that. You say create credential, you put in the path of that storage account, right? TX Tuesday storage, DFS core windows.net. Yours would likely be the same, except with a different name right here. You say with identity, shared access signature, and then the secret is your SAS token. So you need to create a SAS token for this. So what I'll do here is I will go to my storage account, TX Tuesday storage. If you haven't created a SAS token before, this is one of the many ways you can authenticate to the data lake. We go here to shared access signature, and this is how we can create a SAS token. So I want to allow these different resources to access that. And then I want to change the dates here to make sure I'll be able to access it for long enough. So I'm going to put this as to yesterday and this as tomorrow. So I'll be able to use this SAS token until tomorrow at 5:30 p.m. All right. So I will go ahead and hit generate SAS and connection string. This will create my SAS token, which is available right here. So we can copy this token. We can go into Management Studio and just put that right in here. And then we can run this script to create that credential. Okay, so I've created the credential. So now I've authenticated myself to be able to use this credential to access the data lake. All right. So now I should be able to select this and hit execute. And now I can query these files directly. Beautiful. Okay, so I've created this file directly, but I'm specifying a very specific file here. Not super helpful. What if I just wanted to query, all of my data? If I have incremental loads on, I could have 15, 30 different Parquet files in there, right, that are batched away. Well, the nice thing about this is you can actually go in and put an asterisk in here and query using wildcards. So if I did have multiple batch Parquet files, which I don't yet, I could go through and query all of those. Another thing is, what if you have multiple versions, right? And you want to query all the different versions of your data and see what those look like. Well, we can go down here and you can see what I've done here is I've added asterisks in all these different areas. So really what I'm doing is I'm querying every Parquet file within the folder called Human Resources Department. I can highlight that, hit execute, and again, you can see all of my different versions right there. I did order by here, an order by department ID, but you can see there are duplicates, right? So I have this version here and then the same duplicate. And that's because of those two different versions that we saw before within my Human Resources Department folder. So how do I know that I'm looking at the right data, right, since I have these duplicates? Well, we can use something called the FILEPATH function. And this is essentially a field that you just call out here, a.filepath. And that will actually give us the full file path of that data, right? So whatever data point you're returning, the row that you're returning is coming from a specific file path. So we can actually see that whole file path in there, and we can examine that and see these different versions listed out. Now that entire massive file path may be a little bit difficult to work with. Of course, we can use some normal T-SQL functions, some substring function to try and pull that out. But the nice thing about this file path function is it actually allows us to do some really interesting things. So we can put numbers into this file path function, and it will return exactly what is behind and only what is behind that positional asterisk. Okay, so what I mean by that is 1 being the first position, 3 being the third position. So we can go 1, 2, and we see 3 is right over here. So it's going to reveal whatever's behind that positional asterisk. So let's go ahead and run this query to see what that looks like. Okay, so we have my rows that I was expecting. Now I have my ODX version and I have my ODX batch. So this is going to tell us which increment or delta load I've been pulling in. So you can see this first one is extracting the date time part of the file path, just again, what's behind that asterisk. And then this is going to take that and pull in that batch number essentially. And of course, we still have the full file path. But what if we want to only pull in the last version? We don't want this old version that's back here. We only want the latest version. Well, what we can do is we can add a where clause to filter that out. So here what I've done, the same exact clause here. And then what I'm doing here is I'm adding a where clause and I'm saying where max file path. So I'm trying to find the max file path. So let's go ahead and run this query. So this is going to look through, again, same exact file path here, but I'm pulling what is the max version number. Okay, so this is pulling the max version number, and it's going to say, okay, only return the rows where file path 1 is equal to the max file path, which is right there. So I can highlight all of that, hit execute, and again, we can see now we are back to our 16 rows, our latest version of the list of departments, and we have all of that available right here. And again, the beautiful thing about serverless is I'm using typical T-SQL. I can do joins, right? I can join files from other folders, bring them together. I can even create reports and views right on top of the data lake there, which is very nice. Okay, so that's all I have for you today. Want to give hopefully a minute or two for some questions. If there are any questions that have come through, we can do that. Would like to encourage you guys to post any questions you have. If you have any upcoming to the community, please take a look at the TimeXtender community group for TimeXtender Tuesdays. You'll see upcoming topics. If you have any ideas for topics or questions, please don't hesitate to post those. Awesome.
Excellent presentation, Joseph. And Taylor, how are we doing on questions?
We have not had any questions, so I think it must have just been a very clear understanding all the way through.
Oh man, out of the park.
Out of the park.
Beautiful. Well, I'll put in one more reminder just to fill out that survey on G2 if you get the chance today. And also, if you haven't registered for future TimeXtender Tuesdays, make sure to go to the registration page. We'll put that link in the chat as well. And then that way you will get an invite 24 hours before each one of these sessions starts. Anything else we need to announce?